Could Mars have once been a cradle for ancient life? A recent discovery by NASA's Curiosity rover has reignited this age-old question in a thrilling new way. Imagine stumbling upon what looks eerily like dinosaur eggs on the Martian surface. But here's the twist. They're not eggs at all. In a blog update from NASA's Science Mission Directorate on August 15, 2025, https://science.nasa.gov/blog/curiosityblog sols 4627-4628, a ridge stop in the boxworks. The rover team revealed its latest findings from an area dubbed the Boxworks. Here, peculiar rock formations, some resembling clusters of fossilized eggs or even dinosaur nests, dominate the landscape. While these shapes are entirely natural, they've sparked both scientific curiosity and public fascination. But here's where it gets controversial. Could these formations hold clues to Mars's ancient habitability? Or are we letting our imaginations run wild? Let's dive in. Nestled within the Geddes Vallis Ridge on the slopes of Mount Sharp, the Boxworks, dailygalaxy.com, 2025-06, NASA's Curiosity rover, uncovers stunning Martian boxwork, is unlike anything Curiosity has encountered. This region is a geological wonderland, featuring fractured, vein-filled rocks that may encode NASA's most dramatic environmental shifts. These rocks could be key to understanding how water once flowed through the planet's ancient crust, a critical piece of the puzzle in Mars's transformation from a potentially habitable world to the arid desert we see today. Curiosity's journey to this site was no accident. The science team strategically chose this elevated ridge location to study weathering patterns, sedimentary layers, and fluid-filled veins, all signs of ancient water activity. Some formations boast bulbous, clustered shapes, hinting at mineral accumulation or erosion processes that preserved specific structures over millions of years. But what's truly captivating is the mineralogical diversity of these rocks. Many feature deep fractures filled with lighter materials, suggesting episodes of fluid infiltration, possibly from subsurface brines that moved during Mars' climatic shifts. The region's nickname, the Boxworks, comes from its boxy or geometric textures reminiscent of ensuring a stable workspace for the rover's robotic arm and drilling tools has been a delicate balancing act. Unfortunately, the uneven rocks have made drilling impossible here, but the team is using tools like the Mars Hand Lens Imager, MAHLI, and APXS to study surface textures, grain sizes, and elemental composition. Given the area's significance, Curiosity's stay may extend, allowing for more detailed mapping and observations of veins or fractures that could indicate hydrothermal activity, a potential game-changer for habitability theories. Looking ahead, Curiosity will continue its ascent to Kukunan, a site promising unique textures and deeper stratigraphic layers. The mission planners are juggling the need for close-up science with the urgency to explore higher ground, where even older climate clues await. With each sol, the rover paints a clearer picture of Mars's evolution, from a wet, possibly life-friendly planet to the cold, dusty world we know today. But the questions persist. Could Mars have supported life when these veins formed? Were the fluids warm and chemically rich enough for primitive organisms? For now, these remain open debates. But the rocks, with their Earth-like prehistoric allure, are slowly yielding their secrets, one scan at a time. What do you think? Are these formations a smoking gun for ancient Martian life? Or are we seeing what we want to see? Share your thoughts in the comments. Let's spark a conversation.